All right, good afternoon. Welcome to our second session. Today we're going to be looking at multiple choice paper May June 2017 chemistry. All right, you guys would have prepared answers before, so let's get going. All right, so number one, which of the following processes provide evidence of the particulate nature of matter? All right, you can post your answers to the chat board and I'll just respond after you guys post there. Anyone? Good. Kira, Jaden, Sion, S. Excellent. That's good. Very good. So diffusion and osmosis. This would attest to particulate nature of matter. So we're going with B for this one. 1 and 3 only. Yeah? Right. Next up, number 2. Number 2, the item 2 refers to the following table, which gives the melting points and boiling points of the chlorides of 4 elements. All right. Which of the elements forms a chloride that is ionic in nature? We have for this one. Good, Kira. Right, nothing. Good try on. Anybody else? So yes, you guys are all correct. We're looking for one that has a very high melting point and a very high boiling point, right? Because we know the ionic bonding usually is very strong. It requires a lot of energy to break those bonds. So C is our correct answer for that one. Very good. All right. 3. Which of the following elements has 7 electrons on its outer shell? All right, so you're looking for something that's a group 7 element that belongs to the halogens. Yes, very good. That would be D, chlorine, 7 electrons on the outer shell. Very good. All right, moving back up. 5, nope, we had 4. 4. An atom has 20 electrons. When it ionizes, it has the same electronic configuration as which one? 20 electrons. So we need to write this. All right, 10, 18, So 3 shells. Which one is it? Good. I have 2 answers so far. Anybody else? Right, so you're looking for a group 8 element that's in period 3. Right? Because when we ionize, it means that it's going to give up these electrons. This is going to go. So it's actually going to get rid of that. So you're going to have 1 shell, 2 shell, 3 shells. Right? Neon is in the second period. Right? So what we'll be looking at is argon. Argon has the electronic configuration 288. Right? Or atomic number of 18. Right? So B is the correct answer for this one. Very good. 5. Which of the following elements does not form simple ions by gaining or losing electrons? You could do an elimination process here. Which of them you know would form simple ions by gaining or losing electrons? Right, we know for sure that chlorine would. Chlorine just need to gain 1 more. So would calcium and copper. Right, you know copper has 2 plus and sometimes 3 plus. Right, but mainly 2 plus. Calcium, they would lose electrons. Carbon has a positive 4 charge, right? So it doesn't form ions by gaining or losing electrons. Carbon most of the time is going to be covalently bonded, so it's always going to be sharing electrons, kind of like with a methane molecule, right? Looks like that. Or when we do carbon dioxide, and you have 2 oxygen atoms like that, right? So our answer for 5 is E, carbon. Yeah? Everybody okay with that? Just drop a 1 in the chat board if you're all right. Moving on to the other one. Good, everybody okay? 6. Right, 6 is saying some calcium carbonate was reacted with excess dilute hydrochloric acid. the volume of carbon dioxide evolved was recorded and plotted against time. Which of the following graphs would represent the reaction? Right, which of the following? Of A, B, C, and D. Which you guys think is most applicable? Right, what I want to point out in the question here is you have excess dilute hydrochloric acid. So you're going to get to a point when your production of carbon dioxide gas is going to just flatten out. Right? It's not excess. All right, I have 2 responses so far. All right, scroll it now so you guys could see it. All right, any answers? I have 2 so far, 2 answers. Anybody else? So actually the correct answer in this one is not going to be E. I'll tell you why. Because you have chlorine hydrochloric acid in excess, but you have some calcium carbonate. So eventually you're going to reach an end point of the reaction, meaning that all the calcium carbonate is going to be used up, and once that happens, it's not going to be generating any more carbon dioxide gas. There's no more gas that's going to be evolved, right? Think of it like um, a soft drink. If you have a bottle of soft drink and you shake that up and then you open it, right, you're gonna get a loud sound. You know, when you buy like Mario's Pizza and you get the soft drink, after a couple of opens, eventually you're not gonna get any more gas coming out there because all of the gas should be gone, right? So we'll be looking at something more along the lines of, let me just scroll along a bit. C for this one. No, sorry. D for this one, right? Initially, you're gonna have a little bit, right? As it starts to react with more of the calcium carbonate, right? You're gonna reach an end point where you have the maximum amount of volume. Yes, it'll be a straight line, correct? Right? Because one of them is a limiting reagent, and then you're gonna get to an end point of reaction. After this time here, the reaction would stop, right? If we go with E, A is suggesting now you're going to get a flat line here and it's going to continue in times per minutes. And that's not the case because you have a limiting reagent, right? The calcium carbonate would eventually all would react, so it wouldn't have any more. Make sense? Yeah. Good. Nice. So let's look at 7 now. Which of the following represents a balanced equation for the reaction between aqueous silver nitrate and aqueous sodium chloride? Right here we're talking displacement reactions. Yep, I think Jaden has the correct answer. Anybody else? Yeah, correct, Navin. So everybody here has a charge either +1 or -1. Silver is +1, so is sodium. Right. NO nitrate is a minus, and so is chlorine. All right. What would happen is sodium is more reactive than the silver. So sodium will displace silver, right? And you just have that swap taking place there. Right. So any sodium nitrate and silver chloride. Make sense? Everybody all right with that? And silver chloride is not soluble. Yeah? Just drop a one in the chat if you guys okay with that. Nice. Excellent. So moving on to the other one, 8. Which of the following acids will not form an acid salt? Not form an acid salt. Acid salt will be formed with something that doesn't completely ionize. Right, so acid salt has a H inside of there. So strong acids don't usually form acid salts. Yep. So which is the odd one out there? And yep, that's correct. It'll be C. Right? Sulfuric acid wouldn't form a acid salt. That would completely ionize. These are the guys here. Right? This is carbonic acid. This one is phosphoric acid. Right, and here we have our ethanoic acid. All of them is going to have that extra H inside of there. Sulfuric acid, that wouldn't happen. You wouldn't get acid salt when you react with sulfuric acid. Yeah. So C for number 8. Everybody okay with that? C for that one. Nice. Moving on. 9. Sodium reacts with water according to the equation. They give us the molar volume of the gas. They want to know what the number of liters of hydrogen at RTP liberated when 0.1 mole of sodium reacts with excess water. Right, so a bit of stoichiometry here. All right, any other answers? So let's look at it, right? Currently, let me help you a bit to this. Currently, if you look at sodium, 2 moles of sodium produces 1 mole of hydrogen gas. So it's a 2 to 1 ratio. You don't want to work with it like this. You always want to have a 1 to something ratio because that allows you to figure things out, right? So 2 to 1, I reduce this, there'll be a 1 to 0.5. I just divide throughout by 2, right? So 1 mole of the sodium produces 0.5 moles of hydrogen gas. So if I want to find out for 0.1 mole, I just have to multiply this 0.5 by 0.1, right? It's like me saying 5 apples cost $20, right? 1 apple would be $4. How do I get the $4? I divide 20 by the 5. And once I know for 1, I could find for half an apple if I want. I could find for 3/4 of an apple, right? That's how I like to look at this. I like to think of it in terms of ratios. So 0.1 by 0.5. 0.1 by 0.5. Okay. What are we getting there? 0.1 by 0.5 is 0.05. Right, and we're looking at 1 mole. 1 mole is 24 liters. So 0.5 moles will be 24 by 0.05. 1.2 A. Everybody okay with that? We'll go it over again. 2 moles of sodium produces 1 mole of hydrogen. So then 1 mole of sodium would produce 0.5 moles of hydrogen. If I know what 1 mole produces, I could always work out for any other number, right? Because I have the unit value then, right? So if I want to find for 0.1, I just multiply the 0.1 by 0.5. That will give me 0.05 moles of hydrogen gas. So we know in terms of moles, right, if we have 0.1 moles of sodium, it will react and it will give us 0.5 moles of hydrogen. But they don't want this in moles, they want this in volume, right? They want the number of liters of gas. The molar volume of the gas, when they say molar, what they're saying here is 1 mole of the gas is equivalent to 24 liters at RTP. So if 1 mole is 24, then 0.5 moles will be 24 multiplied by 0.5, right? 1 apple One apple costs $2. You can tell me the cost of 10 apples. You can tell me the cost of 100 apples. You can tell me the cost of 50 apples, right? You can tell me the cost of 3/4 of an apple, even if I want to. You multiply that by $2, and you'll get what 3/4 of apple is. So same concept here. Everybody all right with that? Correct answer here, 1.2. Just drop a 1 in the chat if you're okay. Yeah, always find for 1 with the moles. Always. And that'll make your life so simple. Yeah, nice. Everybody all right? Jadon, you okay with that one, right? Just tell me if you want me to go over. Put a 0 if you want me to repeat it, or if you're fine, you'll move on. Just drop a 1. All right, nice. 10. Which of the following oxides may show both acidic and basic properties? Looking for amphoteric oxide. Yep, that's correct. Very good. D, right? Al2O3. Both acidic and basic properties, amphoteric oxide. 11. A mixture of copper 2 oxide and copper 2 sulfate is best separated by which one? D. Navin says the shaking with excess water followed by fractional distillation. Anybody else? You don't know this one? Anybody else have any ideas? Mix your copper 2 oxide and copper 2 sulfate. Copper 2 oxide is insoluble, so that's not going to mix. Copper 2 sulfate is soluble, right? So you could filter this off. Shaking with excess water and then filtering would be the correct answer for this. Yeah? C. Yeah, correct. Yeah, everybody understand now? Copper 2 oxide, insoluble. It's not going to dissolve, right? All your sulfates are soluble with the exception of lead, barium, and calcium sulfate. So if we put this in water and shake it up together and then filter it off, you'd be able to separate. You get the copper 2 oxide remaining in your filter paper and the copper 2 sulfate with, yeah, exactly. So correct answer for this one is C. Excellent. Nice. Moving forward. 12. Which of the following elements exhibit allotrophy? Good. Right. And what's the example? Give me an example. Carbon. What's the allotrophs of carbon? Two of them. Right. Graphite and diamond. Very good. Excellent. Good job. So B for number 12, right? Number 13. Which of the following statements is true of an endothermic reaction? Endothermic. Remember, exothermic, think exit, and endothermic, think enter. So you're going in when you enter, and exothermic exit, you're going out. Right, so N should be this EN here. Yes, that's right. You got it. Heat is absorbed from the surroundings, right? So endothermic. Always think, yes, that's correct, Han. N like enter, exothermic like exit. Exit it going out. So heat is given off, right? Good. Very good. 14 is 14. In which of the following substances will electrolysis not occur when electrical current is passed through it? Remember, you need free electrons or free ions. So stuff, in order to be an electrolyte, it has to be molten, right, or in solution. So which of them there? Yes, that's correct. C, solid sodium chloride. What is solid sodium chloride? What is that? What is this? We don't know what that is. Yeah, that's table salt. Yep, salt in the kitchen. That's add to eggs and whatever else you sprinkle salt on. That's sodium chloride. So in the solid state, obviously electricity is not going to flow through that. Okay. If you melt it, though, is actually an excellent conductor, and they actually use that in industry. All right, nice. Moving on. 15. Which of the following are physical properties of ionic substances? Ionic substances. Yes, I agree with you, Navin. Any other answers? Yes, that's good, Cyan. Right, so high melting points. Good, Kira. Very high melting points. You saw that. I mean, think about, we just saw one. Sodium chloride. Think about melting sodium chloride. And when we melt them, they are good conductors. We just said molten sodium chloride would be a good conductor as well. Right? Not two. They don't need organic solvents. We could dissolve sodium chloride in water. Right? So the answer here is 1 and 3 only. B. Very good. Next, we have 16. Which of the following substances, when added to pure water, significantly increases the water's conductivity? We saw this last week. It's been the topic of our discussion for the last 3 questions. Yes, you are all correct. Sodium chloride. All right, gets in water, it dissolves. You're going to have sodium ions and chloride ions going around there, and that's going to allow the passage of electricity. So that increases the conductivity of water. 17, a separating funnel can be used to separate a mixture of which two? Water and ethanol, water and kerosene, water and solid sodium chloride, kerosene and solid sodium chloride. Yeah, I think everybody already gave me the answer there. Water and kerosene. Yeah, you'd be able to use a separating funnel there. Just tap out whichever is lighter is going to float up to the top. And then you tap off to the bottom. 18 to 19 refers to the following terms. There's ionic crystal, simple molecular, macromolecular, metallic. Which of the above terms describe the structure of sodium chloride? Sodium chloride is the star this evening, boy. Yes, that is correct. Very good, guys. Ionic crystals. Ionic crystals for this one. Sodium chloride. Yeah? Ionic crystals. Good. 19. Which of the above terms describe the structure of copper? Yes, that's correct. D. Metallic. Very good. 20. Which the pH of fresh sugarcane juice, which is usually 5 to 5.5, could be changed to 7.5 to 8 for more efficient processing by adding what? Anybody else? Yeah, you're correct. Slake lime. Yeah, D. Um, it wouldn't be D, because with the slake lime calcium hydroxide, you get the byproduct as water. I don't think you want to add limestone to your juice. Yeah, Caesar base. Yeah, that's correct. Caesar base. So acid and a base is salt and water. And you could probably just get rid of that, filter out that salt. Yeah. 21. Which two of the following statements describe acid salts? Acid salts. See, you have 2 and 3. Anywhere else? Yeah, you're correct. If you remove, you remember I was saying that with the first question, when they were asking about which of them would not form an acid salt. Acid salt is just a salt that has a H in it. So sodium hydrogen carbonate. This is an example of an acid salt, right? But we could get sodium carbonate. I mean, we've seen this before, Na2CO3. So you could get rid of this extra H, right? So saying that is not capable of generating a normal salt, I mean, that's not totally correct, right? The anions cannot dissociate to give hydrogen ions. That's not correct either. So they form a normal salt when all the replaceable hydrogen of the acid is removed. That's correct. And you get sodium carbonate in instance, and the anions can dissociate to give hydrogen ions. Yes, that's possible. So we're looking at C for this one. Yeah. Everybody all right with that? Just drop a one if you are. Nice. So moving forward, 22. A piece of metal is reacted with an acid to produce hydrogen gas. Which of the following procedures should be employed in order to increase the rate of reaction? Right, talking rate of reaction here. Increasing the temperature, subdividing the lump of metal, reducing the concentration of the acid. Yep, that's correct. A. 3 doesn't make sense. So anything with 3 in it is wrong. So automatically, if you realize that and you eliminate 3, then all of this here is wrong. So you're just left with E. 1 and 2 only. Right? Because if we know if we increase temperature, that increases the rate of reaction. Have you ever had to make juice and for some weird reason you end up with cold water and you have to add sugar to that and try to dissolve the sugar, right? The sugar will dissolve faster the warmer the water is, right? So increasing the temperature is actually speed up the rate of reaction. It supplies more energy, so it lowers the activation energy for things to happen. Subdividing the lump of metal, well, we know that increases surface area, so things are able to react faster. Increasing the concentration would help, not reducing, right? So this is wrong. Yeah. So 1 and 2 only, A. 23, the atomic number of an element is defined as the number of what? Another name for atomic number. Starts with P. It's actually called proton number. Yeah, so the atomic number of the element is defined as the number of protons. Yeah? B. 24. See what 24 says. Which of the following halogens is liquid at room temperature? This is another repeat. We saw this last session. You remember this? Let me see. We remembered. Liquid at room temperature. And give me the color. Nobody remember? It's bromine. Right? Chlorine is a gas. Iodine is solid. Fluorine, I think, is a gas as well too. Right? So A, bromine, and it's yellow-brown in color. 25. Which of the following statements is true for the equation below? Hydrogen is oxidized from 0 to +1. I'm not seeing anything with hydrogen being a 0 on the left-hand side equation, so that's wrong. Hydrogen is reduced from +2 to 0. Hydrogen doesn't have much oxidation number. +2 is +1. Mg is oxidized from 0 to +2. That makes sense. Yeah, because that one is look at it is in its solid elemental state, so the oxidation state will be 0. Here, right, SO4, that's a 2 minus, so this has to be a 2 plus here. So C makes sense, right? Nope, this is wrong. It's not +2 on the left hand side, right? So C is the correct answer. Magnesium on the side is 0, right? And then we would see when we move across here, magnesium now becomes 2 plus. Yeah. Moving forward. 26, the element that is used to determine the relative atomic mass of other elements is which one? Common question. Yep. Carbon 12. Yeah, 12 grams, you remember that? 12 grams carbon, Avogadro's constant. Right. 27 to 28. Let's see what they say here. Refer to the following table showing various tests for gases. Right, in answering 27 to 28, each option may be used once, more than once, or not at all. Which test could be used to identify an acidic gas? Acidic gas. So I'll give you an example. Hydrogen fluoride is acidic gas. And that turns blue, litmus red. Good, very good, Kira. E. Good, Navin. So the E as well. Right. 28. Which test can be used to identify ammonia gas? This one. This one. Ammonia gas. Sorry, B, right? Damp red to blue. Good. And then 29, which of the following does not take place during electrolysis? Oxidation occurs at the anode. Oxidation is loss. Anions move towards the cathode. Cations move towards the cathode. Something wrong there, ain't? Inert electrodes do not react with the product. Yep, we all saw it. Anions don't go to the cathode. Anions have to go to the anode. Yeah? Very good. So we're going up again, 29. 30, which of the following diagrams illustrate the cause of an exothermic reaction? Right, exothermic reaction. So if you're more of a math type person, this might help. To work out the enthalpy change, it's usually the enthalpy of the products minus the enthalpy of the reactants, right? Now the enthalpy change for exothermic reaction is always negative, whereas the enthalpy change for endothermic reaction is always positive. So if you just use this equation here, you'll be able to know which one has to have the bigger value. If you want to get an overall negative value, then our reactants, the energy of the reactants, has to be higher than the products. So we are looking for any answer here where our reactants is shown higher than the products. So yeah, I guess that'll be A. Is the only one where reactants is higher than our products. Everybody okay with that? Make sense? That should be an easy way to remember energy profile diagrams and how we're getting negative and positive enthalpy change. Right, so this equation, you need to know this one here. If you know this, then your life much simpler when it comes to energetics. Right, enthalpy change is the difference between the enthalpy of the products and the enthalpy of the reactants. Exothermic reaction has a negative enthalpy change, so reactants is higher. Endothermic reaction has a positive enthalpy change, so that means our products has to be higher. Make sense? Drop a 1 if it makes sense there. Nice. Good. Makes sense. 31. An atom with atomic structure, that's what? 27. 13x contains what? So A has 14 protons, 13 neutrons. That doesn't sound too correct. Neither does B, neither does D. So yes, Navin, I'd agree with you there. C, 13 protons, because that's my proton number, and then the difference between these two should tell me what a number of neutrons are. So the number at the bottom, right, the number at the bottom is always the proton number, or what you call the atomic number, and the atomic number tells us the number of protons. Right, to the top is our mass number, and that's actually the sum of protons and neutrons. So if the mass number adds up to 27, and we know that the number of protons is 13, we just do a simple subtraction to get what our number of neutrons are. Nice. 32. 32 refers to the following graph, which shows the boiling point of some straight chain alcohols. Which of the following molecular formulae represents the alcohol whose boiling point is 180? 180. So this is 60, 70, 80, somewhere here. Bam, 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 bam. There we go. Lines up there and drop it down. What we get? 7 C's. Right? Which of these have 7 C's here? No seeing? Yep. 7 C's. Usually subscripts at the outside. So check this, right? 3 by 1 here is already 3. So 3 and 1 is 4. This one has 4. So 4 and 1 is 5. 5 and 1 is 6. 6 and 1 is 7. So we know D has 7 C's in it. Right? And we know if we have, it should be that 7, this should be what? 2n plus 1, 15, and the OH molecule as our general formula for alcohol, CnH2n plus 1 OH. Right? I'm going to have that here. Make sense? D is our answer for this one. 33. To which homologous series does the following structure belong? Right, we're looking at the functional group, and that would help us with the homologous series it belongs to. Yes, this is your carboxylic acids. Very good. Right, carboxylic acids has that COOH as their functional group. Nice. 34. Which of the following is the name of the compound? 1, 2, 3, 4. Met et prop but. 1. Jaden has D. Anybody else? What is it? Yeah, good. Butanol. Right, so we know it's 4. Actually draw it out. Well, how come you all didn't go with the C? Why you all choose 1? Just curious. What was your reasoning? So I want to see what you're all thinking. You're correct though, eh? I just want to see a trend or thought. Nobody? Or your guess? Let's see, 35. If we flip it around, be 1, but be A, okay. Yeah. Yeah, correct. All right, good. Nice. Just making sure. 35. Which of the conversions above correctly represents the dehydration of ethanol? What happens when we dehydrate ethanol? It goes back to the what? We lose that OH and it becomes a dehydration of alcohols. Alcohol and goes back to something. It's a hydrocarbon. Give you a hint, it's unsaturated. And the answer is 35. Use concentrated sulfuric acid and you heat to 170 degrees Celsius and it produces, nope, not D. We ain't burning it, we dehydrating it. B. This is what's this? You know what this is? I don't think you always do this at CXC. I think I do this at A levels. This is something called a ketone now, aldehyde. You'll do aldehydes? I don't think so. That to me, that was Form 6. B or C is C. This is it here. Alcohol, to dehydrate alcohol, use concentrated sulfuric acid, right? And you heat it to 170 degrees Celsius. What happens is you lose the OH and you get the alkene and water as the byproduct. Right? They didn't put the water here, but I mean, I guess you lose the water as steam anyway, or liquid. But C would be the correct answer. You dehydrate alcohols to get the alkenes. And you know this is an alkene because C2H4. You didn't see the water, yeah. Yeah. But the others wouldn't work because this is a carboxylic acid. This is what you call a ketone. This has that functional group. I don't think you'll do that until they go in A levels. I think you'll just do the acids, the esters, the alcohols, alkene. Everything is just be a big blue to me. Form 5 and Form 6s get mixed up sometimes. Yeah, but when you dehydrate the alcohol, this would be a more suitable answer. You're definitely going to get alkene. The last one wouldn't work because that's when you burn the alcohols. You're going to get energy, carbon dioxide, and water. Right, so 35 is C. Right, you get the alkene. In which of the conversions above requires potassium manganate? Which of them requires that? Anybody remember that one? Let me just clear the screen. Right, I'll give you a little hint. Oxidation of alcohols. If I add oxygen to the alcohol, what's going to happen? The oxidizing agent is going to provide, yep, that's correct. E, you're adding oxygen. Look at it. Look at this one here. And then we add oxygen. The oxidation of alcohol, right, or the use of potassium manganate or even potassium dichromate, acidified potassium dichromate or potassium manganate, is going to take us from an alcohol to a acid, carboxylic acid. Right, so 36 is A. Yeah. Are you right with that? 37. The forward reaction is known as what? They're talking about this here. Organic acid and alcohol to give a ester and water. When we go forward, it's called, the answer starts with this. Yep, that's correct, esterification. And the reverse, what's the reverse? When you go from the ester back to these two. Yeah, that's number 38. And there are two types. What's the two types now, Vin? I'll give you one. There's acid hydrolysis. And the other is the opposite acid, which is, yep, alkaline hydrolysis. The alkaline hydrolysis is what they really use when they do these soaps. Yeah. So B for 38, reverse the reaction, going from the ester back to the acid and the alcohol. That's hydrolysis. Right? 39, cracking, the process of breaking down what? Cracking is a process of breaking down very good, Cristiano, breaking down large alkane molecules into smaller alkene and alkenes that are more useful for industry. All right, so that's 39 is A. All right, back up to the top. 40. Which of the following processes correctly describes the equation above? So I am seeing an acid here, a base, a salt, and water. What's this? What's the reaction when an acid and earlier base? I'm going to say alkali. Yeah, salt, water. This is a neutralization reaction. Yep, that's it. 41. An organic substance, when reacted with bromine water, decolorize it immediately. The substance is most likely a. Was the test for our alkenes? Or is test for the saturation or unsaturation rather of a hydrocarbon? They use the halogens. So if it decolorize it immediately, the answer for this one is what? Give you a hint. So alkene. That's our test for our difference between the alkane and the alkene. You could either use the bromine. What else we could use? We saw it a little while ago. Acidified potassium manganate, right? If the double bond is present, you'd have rapid decolorization. So bromine vapor, bromine and water, or sometimes they use tetrachloromethane, and there's also acidified potassium manganate. For the bromine, you have a rapid decolorization of the solution. Same thing for the acidified potassium manganate, right? Same thing for bromine vapor, right? So alkene. This is a test for saturation, unsaturation. 42. Glucose is converted to starch or cellulose by what? So glucose is a naturally occurring polymer. There are two types of polymerization. That's a clue. Any guesses? I take it none having. Anybody else? So there's only one monomer unit that's undergo addition polymerization. Was that monomer unit Navin? So there are two types of polymerization. There's addition and there's condensation. Addition would be for alkenes, right? So you have polyalkenes. We also have, like, when you're doing PVC, right? The name of PVC is, I'll tell you what it is, vinyl chloride, right? So those undergo addition. Everything else is condensation. They're called condensation, yeah, polyvinyl chloride. They're called condensation polymers because they all involve the loss of a small molecule. Usually that molecule is water, right? So glucose is a naturally occurring polysaccharide, not glucose. Starch is a naturally occurring polysaccharide. The monomer unit that you make starch from is glucose. Make sense? Right, I remember glucose is C6H12O6. Glucose is actually one of these ketone aldehyde, right? So they lose. I won't go into that. It'll be a little difficult, confusing. But essentially, what happens with the condensation polymerization? Let's just say you have the H and the O, right? It loses a H and a O, and that comes off as water, and that's where you have the joining of the two monomer units, right? To continue like that and move on forward. Right, so correct answer for this one is condensation polymerization, right? Addition polymerization is only for alkenes, right? Or if alkenes have a halogen on it, like this, right? This one gives you the PVC, right? So only alkenes undergo addition polymerization, right? Remember that. All right, so we're going again. For the three compounds in a homologous series, they what? Exist in the same state, possess the same molecular formula, differ by successively by CH2 groups, possess only carbons in straight change. Same molecular formula. Anybody else? Same molecular formula. Good. Actually, you have, they do exist in the same state because just for alkenes alone, or alkanes, the smaller ones are gases, and as you get bigger, they become liquids and solids, right? Molecular formula changes. They don't only possess carbon and straight chains, they could have a halogen inside of there, like I showed before, but they do, each member differs in a molecular formula from the next by a CH2 group. I know the empirical formula is different either, so I'm a little more tempted here with the C than the molecular formula. They don't possess the same molecular formula. What they possess is the same general formula. Yeah? Everybody all right with that? Yeah, empirical formula is different. Yeah, I know that for a fact. All right, same functional group. They have the same general formula. Members show similar chemical properties, and that's because the functional group reactivities decrease as the number of carbon of atoms increases, which would make sense, right? Physical properties is change as the number of carbon atoms increases, and that will make sense as well. So things like melting point, boiling point, density, that would increase as the chain gets bigger, right? Now, each member, right, in the molecular formula, think about it. Every time you add on another carbon, it's going to increase from the next by a CH2 or by the relative molecular mass of 14 grams, right? And you would prepare all members by a similar method. So C is a bit more appropriate, right? General formula, yes. Molecular formula, that's a little iffy. Yeah? So 43, C. 44, ethene reacts with hydrogen, chlorine, and hydrogen chloride. These reactions are all examples of, right? So the double bond is broken when that happens, and they move from an alkene to an alkane or haloalkane. Yes, that's correct. Addition, right? Alkenes undergo addition reactions, right? Alkenes undergo addition reactions. Alkanes undergo substitution reactions. Yeah. So A, addition. No other products. Yes, correct. No other products. Addition. So essentially what happens is if this is ethene and I react this with chlorine, chlorine would eventually attack the double bond, attack that double bond there, and it would attach itself onto the carbon. Carbon could take up to 4, right? So we could end up with 2 chlorine inside of there, and that's how you get the vinyl chloride. Yeah? Which of the following substances is not a polymer? Was not a polymer there. Fructose, yeah. Fructose is not a full chain polymer. Fructose is a simple sugar, right? Nylon, yes. That's from that's like what you're using ropes and stuff on the monomer unit. There is a diacid and a diamine. Right, they usually use a diacid and a diamine. Proteins, they get that from amino acids. Cellulose is pretty much starch. You get that from glucose molecules coming together. Yeah, so 45 is E. Good job. 46, which of the following methods is used for the extraction of aluminum? What we use for aluminum? No more organic, it seems. Right, aluminum is what? Need high temperature. A, yes, correct. Electrolysis of its molten oxide. That's how we get the extraction of aluminum. Yeah, you remember that? 47, which of the following statements about sulfur are true? This is a repeat. We saw this before too. Yeah, you remember it? Yeah, Christiana, remember it. Having those two is using the vulcanization of rubber. We know it's not using the extraction of iron, as I was saying last time, so we could go with the process of elimination and take that out. Right, so it's not using the extraction of iron, so it's everything that doesn't have 2 in it. So we want 1 and 3 only, which is B. All right, moving back up to 58. 58, let's see 58. Why is this not moving? One sec, guys. Right, soapless detergents are made from fats, made from all biodegradable inorganic materials not affected by hard water. Any answers here? Correct answer here is D. They're not affected by hard water. Right, that's the type of detergents you'd use when you have when you know your area is one that has hard water in it. Hard water doesn't allow you to lather a lot. Yeah. So D is the correct answer for that one. Right, 49. Which solution, when treated with sulfur dioxide gas, becomes green? The solution contains potassium. This is an easy one. Yes, that's correct. Which one of those we know turn green? We know potassium manganate is purple. Potassium dichromate. Sec, where's my pen? Oh. C, potassium dichromate. Yeah. 50, a suitable drying agent for the laboratory preparation of ammonia gas. Oh, we get there. Drying agent. Yes, that's correct for the breathalyzer test. So if you have alcohol in your breath when you blow, it'll turn green. Yeah, that's exactly. No, I don't think they do that. They have a digital something and you add a blue and it's give you a particular level. That one you're talking about is probably the older ones, but it used to work based on that premise. The presence of the alcohol in your breath is oxidize the potassium dichromate and cause the color change, and that's how they used to detect it in the past. But now they get more sophisticated, so they have levels, the amount of how intoxicated you actually are. So they could either lock you up or get somebody to come and pick you up or call TT ride share to come for. So 50, preparation of gases. What is used as a drying agent? Start with calcium. So you can get rid of C and D one time. I get a little clue there. B, calcium chloride. Nah, it's the next one. Calcium oxide. Right? This is the diagram where they have the ammonia salt and the alkali. Usually they'd use like some like calcium hydroxide. Right? So this is the preparation of ammonia. And they have this funny kind of tube that would connect the reacting beaker or to another tube with the drying agent in it, so you could get the it could take out the water. Remember that? Not sure about this one. Yeah, it's calcium oxide is the drying agent. All right. So for 50, suitable drying agent for the laboratory preparation of ammonia gas, calcium oxide. What I'll do is I will send you some pics or the setup for a couple preparation of gases, or maybe I could do that as well. I didn't do any handouts for the chem classes yet, so I'll do a handout on laboratory preparation and identification of gases for you guys. Right. Another common one is a qualitative analysis, but luckily you don't have a lot of that here. 51. When copper 2 carbonate is heated alone in a dry test tube, a gas is evolved and a black residue is formed. This gas is expected to do what? Copper 2 carbonate, relight a glowing splint. Only oxygen is relight the glowing splint. Decolorize acidified potassium, form a white precipitate with calcium hydroxide. Which one? Copper 2 carbonate. A black residue is formed. What's that black residue? Yep, you're correct. CO2. So white precipitate with aqueous carbon, yeah. Because anytime you heat you test for ions. If you have a carbonate present, CO3, right, you're gonna have carbon dioxide gas being evolved. Right? So that's the same thing I was now talking about, qualitative analysis. Yeah. So I'll do that as well. Usually when they have people to like do an exam prep, I would do flashcards with my students, because that qualitative analysis is usually give everybody a little trouble. So the gas that you get evolved when you burn this is carbon dioxide gas, and we'll test for it with calcium hydroxide. That black residue is copper. The copper is left in the glass tube. That's what remains there. Right? An element in it is a non-metal. That is non-metal is what? A solid at room temperature, can act as a reducing agent, forms an acidic oxide, conducts electricity. Which one? Non-metal. See? Non-metal. So think about it like this, right? A non-metal was a property of a non-metal. A non-metal would not be in group 1, 2, and 3, right? Group 1, 2, and 3 metals, they lose electrons, and loss of electrons is associated with oxidation. Our non-metals, which is in group 5, 6, and 7, they have to gain gain electrons in order to complete the outer shell to get a noble gas structure, right? So reduction, or RIG, is associated with the gaining of electrons. So let me see. When they're oxidized, they are a reducing agent, and when they're reduced, they're oxidizing agent, right? So that eliminates this one. Solids at room temperature is also wrong. They don't conduct electricity. So yes, we will be with C4 acidic oxide. Yeah, everybody okay with that? Yeah, nice. Moving on. Next page. One sec. 53. Which of the following observations is likely when excess aqueous ammonia is added to a solution of copper 2 sulfate? Excess aqueous ammonia, copper 2 sulfate. What will happen? Any answers? Deep blue solution. See? Yes? That's correct. It's another qualitative analysis. So you use aqueous ammonia to identify cations, right? Usually is an excess, dropwise followed by an excess, right? Some of the color changes you'll get with aqueous ammonia is white precipitates, blue precipitates, dirty green precipitates, or rusty brown precipitates. The last two, dirty green and rusty brown, that's usually iron. Your dirty green is your iron 2 plus, your rusty brown is your iron 3 plus. Blue, anytime you see that blue, always think copper, right? Especially copper 2 plus. Green precipitate, that wouldn't happen with your, green precipitate, sorry, would happen with your iron. I talked about that already. Green solution, well, remember, when you do these tests, you're looking for precipitates, right? Not so much solutions. Yeah, everybody okay with that one there? So that's two things. I would look at identification of gases and probably a handout on qualitative analysis for you guys. So able to identify presence of cations and anions. All right, so in answering 44 to 45, a particular metal may be used once more than once or not at all. It's the same thing again. Which metal reacts vigorously with water to produce a strong alkaline solution? Yep. Anybody else? Vigorously with water is your key here. You're looking for the most reactive metal. So this is reactivity series. Somebody had a really nice mnemonic last time we chat on remembering the reactivity series. Mine was people sometimes collect magazines about zoos in London having cute monkeys and small gorillas. And that worked for me. I'll probably have some cooler ones now. So strong alkaline solution, right? Sodium, think about it. Sodium hydroxide, that's a strong alkaline solution. So that's a kind of giveaway there. Which metal has an alloy which is used in the manufacture of aircrafts? Yep, aluminum. Aluminum is light, it's very durable, and it's very corrosion resistant, right? So A for aluminum. 56. Which of the following reactions is least likely to occur? Least likely to occur. This is a repeat from last time, is it? No. Similar though. Least likely to occur. So reactivity series. We saw this earlier, magnesium and zinc. People sometimes collect magazines, so magazines, yes, magnesium can displace zinc. Right, copper could displace silver. D, lead can displace iron. People sometimes collect magazines about zoos in London having in London iron and then lead. Yeah, iron is above lead, so lead can't displace iron here. Seen it? Lead can't displace iron here. Iron is above lead. Make sense? Drop a 1 if it does. Nice. 59. Sorry, no, 58. Skipping 1. Which of the following observations is wait, no, skipping 2. 57. The main substance is responsible for acid rain. Saw this last time. This is a repeat. Good. Anybody else? You remember this from last class? Sulfur dioxide and sulfur trioxide. Remember rainwater. Water and this is going to give you sulfuric acid. Yeah. 58. Which of the following observations is expected when aqueous silver nitrate is added to aqueous potassium chloride? A pungent gas is evolved. A blue precipitate appears. A white precipitate appears. Silver nitrate. That's a test for anions. And you get a white precipitate. C, that's correct. This, I believe, was here last time too. We did this in the last paper. Right, 59. Which metal appears between copper and aluminum in the reactivity series? People sometimes collect magazines about zoos in London. Yeah, B. Hemoglobin part there. Gave it away. Iron, that's true. Right. 60. Which of the following gases will give a positive test with dry cobalt chloride paper? Test for gases. Anybody knows? There's only one thing that I could use dry cobalt chloride paper for. Well, we know the test for oxygen is, you guess, in C. Well, no, you just remember we just saw we used the lime water. Carbon dioxide is still in lime water, milky, right? Hydrogen is make a glowing splint out with a pop, and oxygen is, yeah. So you do a process of elimination if you're not sure. Oxygen is rekindle the glowing splint. You need oxygen for fire to take place. Right? That's why, like firefighters, they try to stifle the oxygen. So water vapor, this is not just water, it's water vapor is what gives you a color change with the cobalt chloride. It goes from blue to pink. The color change is blue to pink. Yeah? Water vapor does that. Everybody okay with that? So you still have a few minutes. I had another paper here, so you can do some practice. In which of the following situations is Brownian motion demonstrated? Brownian motion. This is like with dust particles or something else. Something from a flower. Yes, A. Right, Brownian motion. You ever notice, like in the evening time when sunlight shines through your window, you actually like see the little dust particles there. If you just look at the real light, you'd see dust particles, and that random motion that you'd see the dust particles making, that's Brownian motion. Or if you ever see pollen grains in water, I think the dust particles would be a little more common. Which of the following properties above refer to a neutron? This is a repeat, a neutron. Yes, no charge. We're looking for something with zero charge. So B is the correct answer for this, right? 53. From the table below, which of the substances represented by the options A, B, and C is most likely to be sodium chloride? Which one? Sodium chloride. I see no A from it there now. I don't know if that's from the last one or... Yes, it's for this one. And anybody else? This one, okay. You guys there with me while you're sleeping? So A would be correct for this one. You're looking for something with a high boiling point. It doesn't conduct electricity in its solid state. We know this. Yes, that's good. J done A. And it does conduct in the aqueous state. So that's correct. Right. 4. Which of the following compounds is soluble in cold water? In cold water. Soluble in cold water. I think this is another one I would like to do for you guys. Something on your solubility of salts. Yeah, you're looking at that. You want the solubility of salts, identification of gases, and some qualitative analysis. Test for your anions and cations. Want some notes on those? Is soluble, eh? Yes. Chan says yes. Christian said yes. Yeah, no problems. I'll put those together for you guys, right? For this one, lead chloride, nah, nothing. It's not lead chloride, no. All the chlorides are soluble, but lead chloride is soluble in hot water, not cool. It's insoluble in cool water. So let's see, sulfates, all sulfates are soluble except lead sulfate and barium sulfate. Nitrates, nitrates are all soluble. Yeah, correct, very good. Yes, that's one of the exceptions for the chlorides. For the chlorides, the lead chloride is only soluble in hot water. It's insoluble in cold water. And here they want us soluble in cold water, right? So guys, any nitrate, hot water, cold water, doesn't matter. All your nitrates are soluble. All right, so always remember that. All your nitrates are soluble. 5, which of the following oxides show both acidic and basic properties? We saw this one already. And I was telling you about that. It's called an amphoteric oxide. You remember? What is it? Aluminum oxide. And that's an amphoteric oxide. 6. Which of the following statements best Which of the following statements best describes the difference between an atom and an ion? We saw this one already. Yeah. You remember this? Atom contains equal number of protons and electrons. Ions contain unequal number of protons and electrons. Right? So this one, D is my correct answer. Moving on. 7. What type of reaction does the equation above represent? This is what I was telling you about earlier with the addition reaction. I kind of give you the answer there. Right? So you see what happened here for yourself. The chlorine has attacked this double bond here. And when it breaks the double bond, remember carbon could form up to 4 bonds. So it inserts itself here. So this is an addition reaction taking place. Yeah? Which of the following is classified as a neutral oxide? Neutral oxide. So it doesn't show acidic or basic properties. If you guess carbon monoxide, you are correct. Carbon monoxide is a neutral oxide. Yeah? D as a neutral oxide there. Right, almost done. We just go up to 10. 9, an element X has an electronic configuration 281. At which of the following positions in the element it is the element in the periodic table? Right, so period 3, group 1, C. 10 and 11, when a compound is treated with concentrated hydrochloric acid, a greenish-yellowish gas which bleaches moist red litmus paper is given off. The gas given off is, everybody should know this one. We did this one last week. What's that gas? And they kind of sell it out here, hydrochloric acid. Yes, that's correct. E, chlorine, right? Excuse. And we know that it's chlorine because it bleaches the red litmus. The concentrated hydrochloric acid is acting as a what? Reducing agent, oxidizing agent, acid, a catalyst. But we don't have enough information to determine if it's a catalyst or not. So we can't say that, right? We know that a gas is given off, and the gas, when it's given off, has an oxidation state of 0. Right? On this side, chlorine has an oxidation state of -1. So it is what? Losing an electron, right? In order to become in its elemental form at oxidation state of 0. And since it's losing an electron, whatever is being oxidized is the reducing agent. C. Make sense to everyone? Drop a 1 if that makes sense there. Yeah, there's a few more. We had started a little late. 2 solutions are to be mixed in order to demonstrate endothermic change. Which of the following technique would be most appropriate? This is an easy one. How are you going to test for enthalpy change? You always check what? Heat we're measuring here is heat. So a temperature change. Yeah? 13 crystals of sodium chloride are best described as, everyone should get this, ionic. Very good. All right. 14 ethanoic acid reacts with ethanol to form an ester on water. How many moles of ethanoic acid are required to produce 0.5 moles of the ester? So you just need to remember your reaction of ethanol and ethanoic acid. And once you do, you'd have the ratio in which they're going to be reacting. 0.5. A 1-to-1 ratio. Yeah, it is a 1-to-1 ratio. Yeah, so 0.5 to 0.5. B. That's correct. Right? The reaction is CH3. COOH is the ethanoic acid. And ethanol here is C3H7OH. Right? I run out of space, so I'll just put it here. And that gives me ethyl ethanoate, which is C3COOC3H7 plus H2O. So 1-to-1 producing 1. So if you're using 0.5 moles, if we want 0.5 moles of the ester, we'll be using 0.5 moles of the acid. Yeah, everybody okay with that? B? Just drop a 1 if you're right with that. One more and then we could wrap up there. 15. From the time you see this, what are they talking about here? Just write the name of the allotrope or carbon that this diagram, yes, that's correct, graphite, right? And we know that because we have the hexagonal layers on top of each other, and we know that these bonds are weak, so they could slide on one another, so it makes it a good lubricant, right? But these bonds inside here, inside of the hexagon, are generally strong, right? So they're asking us, was the diagram above represents the arrangement of the atoms in? And my answer for that would be what we just talked about there, graphite. Yeah? All right, let me just stop the recording.